This week, it's the race back to space. We'll hit the road, build a house, and lock up some astronauts.
Jump on in.
Thank you. So you're not using the steering wheel at all, you're using a... Oh, wow! Which way are we going? Which way are we going?
I'm at NASA in Houston, where Lucian Juncan is taking me for a spin. Using both a steering wheel and a joystick, you can point this vehicle in one direction and drive it in another.
You feel the forces in your tailbone.
Oh, I can feel the forces in my tailbone.
And if that seems really confusing, well, it is. But this is drive-by-wire technology, which means the onboard computer works out which way you want to go and then calculates what to do with the wheels.
All right, so we'll just go this way.
This is just one of many experiments into how we might live, work and drive on the Moon or Mars. Although this vehicle may also pave the way for smarter cars in smarter cities back down here on Earth, where I have to say, parking may be one of the coolest things you get to do.
No way! No way! Come on, man.
But before we start driving around celestial bodies, we need to get there first. In the days of the moon landings, only 2 competing countries were locked in battle, driving space exploration forward. Now, in the race back to space, the power's shifting. Earlier this year, China's Chang'e 4 probe was the first spacecraft to land on the far side of the moon, and Europe, India and Japan are all pushing forward with their own space programs. Back in the US, NASA plans to get back to the moon by 2024, but now it has competition from private individuals, an idea that would have been laughable 50 years ago. Rival billionaires Elon Musk, founder of SpaceX, and Jeff Bezos, who owns Blue Origin, are racing to populate the moon and Mars. But what kind of person would actually be on these spacecraft?
The first people to go to Mars will be risk-taking adventurers, accepting that they may have one-way tickets or have a small chance of return, and they will be probably financed or sponsored by one of these private companies.
At NASA, we discovered a little-known department where these risk-taking adventurers live.
Right now, there are 4 astronauts inside a spacecraft on a mission to Phobos, one of Mars's 2 moons. But they're actually in there.
Yes, in this tiny habitat, volunteers are locked away for 45 days on a simulated mission, with cameras and scientists monitoring their every move. This is NASA's Human Exploration Research Analog, HERA for short.
This is so cool. What's really funny is that everyone that works around here has to be really quiet all of the time, so they don't remind the astronauts about the outside world.
Inside the module, the crew is poked and prodded in different psychological experiments, from sleep deprivation to diminished privacy, all to fine-tune a critical component that could make or break any future mission to Mars: the humans inside the spacecraft.
The primary purpose of HERA is to learn about the effects of isolation and confinement on people. So a lot of the studies that we do are behavioral or psychological in nature, looking at the type of isolation from people. So you're really only talking to or in contact with the other crew members that are in the vehicle with you, or mission control that's supporting you.
Yeah, astronauts on future missions to Mars have more to worry about than the toxic soil, the deadly atmosphere, and high levels of radiation. They also have to worry about each other. And it's hard to say which of these would be more likely to result in someone's death.
And it's consistent low-level stress over time. Little things start to grate on you because stress kind of heightens how you react to the things around you. So the sound of somebody chewing the cereal next to you might be fine at first, and then 45 days later, you really, really don't like that sound.
Even for an astronaut, the psychological demands of a journey to Mars will be extraordinary. The spacecraft will only be the size of a small flat, and the round trip will take almost 3 years. Add in 4 different personalities cooped up together, and you may run into some problems. And with a range of characters needed, you never know who you could end up with.
Okay, this is MCC, the Mission Control Center. This is Leslie, and that's Ted. These are the people that the crew talk to. The only people the crew talk to as part of the mission. And I like this bit over here. Look. The smoke and fire button. So I guess if things get a little dull, let's just make it a bit more spicy in there. Virtual windows. This is what the crew see when they look out of the virtual windows on board.
The habitat and workload are designed to mimic a real mission as closely as possible. And NASA's scientists throw in lots of elements to try and ensure that the volunteers forget that they're actually part of an experiment.
If MCC talks to the crew, they ask a question. It takes 5 minutes to get to the crew, and then if they answer, it takes 5 minutes to get back. So a 10-minute round trip for a question and answer. So the whole idea of creating a mission scenario, you're going to Phobos, you're gonna do an EVA, you're gonna pilot a small spacecraft to the surface. All that keeps them really excited and engaged in the simulation.
The goal here is not just to study the effects of isolation and confinement, but also to work out how to put together the perfect team for extreme space travel.
It's all about the mix. And that's one of the things that we're looking at is what is that right mix? Or given the particular mix of people, you have, let's say, 1 strong personality and 3 less strong personalities, what would we expect that to play out like? So what kind of roles do you need to have a successful team for a space mission? And they were looking not just at the functional roles, a commander, a medic, an engineer, but they were also looking at the social roles and found that those were just as, if not more important for those long duration missions. Having somebody that's providing humor or entertainment for the crew, that's way more important.
And it won't just be down to humans to decide what the right social mix would be. Masses of data is being generated from these experiments, making successful social interactions quantifiable.
One of the research studies that's actually going on is looking at a way to get a little bit ahead of the personality problem by developing an algorithm where you can take the background information on individuals, personality tests, that sort of information, plug it into the system, and based on the characteristics of all the people that you're putting in that team, figure out how they're going to work together, whether it's the right mix of people.
Unlike these potential Martian voyagers, we may think that 3 years in isolation is a bit bonkers. However, from Jeff Bezos to Buzz Aldrin, many are dreaming of trips to and even living on the Red Planet. But Lord Martin Rees, Britain's Astronomer Royal, doesn't actually think that most of us are suited to space.
Nowhere in the solar system anywhere is as comfortable as the top of Everest or the South Pole. And so that's why I think the idea of mass emigration is a bit crazy. we have to bear in mind that space is not a place for human beings, except for adventurers, the kind of people who do go to the South Pole and top of Everest.
What do the Hera crew think about the experiment? Well, we caught up with them, unsurprisingly out in the fresh air, shortly after they left the habitat.
You know, since we're all very similar, if we had one very extroverted person with maybe a strong personality that was slightly different than the group, that might have negatively affected the outcome.
If you put 4 extroverts in there together, they're going to drive each other crazy eventually. Maybe 4 introverts aren't going to be able to come together as a team as much because they're more inwardly focused. You want a good blend of people who are adaptable to not only the situation, but to each other's personalities.
You have a mission to Mars. The goal is so huge in all senses that you're extremely motivated. Even, the aim of the analog is to be one step closer to put humans on Mars. But I can imagine being in such a situation. Your motivation is so huge that I think that it would be like even you can overcome anything.
Hello and welcome to the Week in Tech. It was the week that Facebook came under attack in the US Senate over its plans for cryptocurrency Libra. The US Air Force have warned people not to go near Nevada military base Area 51 after more than 1 million people RSVP'd to a Storm Area 51 event created on Facebook. And computer pioneer and celebrated codebreaker Alan Turing was revealed as the new face on the British £50 note. Elsewhere, Elon Musk announced more detail of the work being carried out by his neurotechnology company, Neuralink. The company plans to insert threads into paralysed people's brains and said that the technology has already enabled a monkey to operate a computer. New emojis featuring disabled people with a range of impairments have been announced for Apple and Android. Smiley face, thumbs up. The new emojis, which include wheelchair and guide dog users among others, were shown off on World Emoji Day. If your sat-nav got you more lost than usual this week, it might have been the satellite's fault, not your devices. Galileo, Europe's GPS network of satellites, has had a bit of a fandango and has been offline for almost a week, with no word as yet on when it might be switched off and back on again. And finally, MIT have developed a new way to make drones seem even more sinister. Whereas existing drones are either fixed wing like aeroplanes or propeller driven like helicopters, researchers have created a new type of hybrid craft with the benefits of both, which means they can both hover and glide and take off vertically. Those Jetsons hover cars get closer by the day.
This is how the Apollo astronauts got about on the moon. Seems pretty racy, even by today's standards. But the next time we go to the moon and Mars, our vehicles will look a bit more like this. With 6 wheels, all of which can turn independently, this is the latest NASA prototype of the vehicle that could be crawling over the lunar surface very soon.
So we're designing the next vehicle, and the next vehicle goes up in 2023. It's pretty aggressive. We love it. It's like Apollo.
To make the drive as safe as possible, the active suspension keeps equal pressure on each wheel at all times. Wow. And that means you can cover some pretty extreme terrain. Oh my word. Are we about to go down that?
We can if you like.
I would like.
It's not worth it. It's not worth the enjoyment. I have children at home. So.
Oh my goodness. This vehicle is already being used to test the practicalities of future moon missions. 4 astronauts take 2 vehicles out for 2 weeks at a time, living and working on board, to work out the amount of food they'll need and the kind of living conditions they can expect. By the way, we're on a slight incline right now. So what I can do is I can actually put my head in this little bubble here and I can investigate the rock, which is a great design feature. All right. I'm examining lunar rocks. It's like a glass-bottom boat. progress across the terrain will be slow and steady because this will be a really harsh environment. And moon dust is really rough.
Yeah, it's really
sharp.
It's shardy. Those are things that we definitely know from Apollo. Think of taking a glass and just slamming it down and then crushing it with your feet. And those shards is kind of how it is on the moon, since there's no erosion or wind to tumble those little pieces. And that's one of the reasons we're pushing to have suit ports with the space suits on the outside of the vehicle. So on the back at the end of these beds back here, there's a door to the vehicle. So you open the door to the vehicle and you're now staring at the back of your suit, and you climb into the back. So now your suit and your cabin are pressurized. You seal it up and then you close the cabin door so you can go climb in a spacesuit while I stay in here, and we don't have to depressurize the cabin.
And that means all of the moon dust that collects on the spacesuit never gets into our atmosphere.
Yep.
The whole suit stays on the outside of the vehicle. That's
Exactly.
genius. Mind you, moon dust may have its uses as a building material. And that's something that Lara Lewington's been investigating at the European Space Agency in the Netherlands.
This structure has been 3D printed using a combination of elements that could be found on Earth that replicate the qualities of moon dust. And that means that things can be tried here before actually being attempted on the surface of the moon. And the hope is that one day creating something like this, inhabitable by humans, could be possible. This moon regolith or simulant is hoped to be able to create an inhabitable structure that's temperate and can block radiation.
So you have actually the powder in a layer, and then you spray with a nozzle the binder material. The binder material here was an inorganic salt in water, and then it comes to a chemical reaction like concrete, if you like, and you build more or less a solid structure, layer by layer.
This substance isn't quite perfect though, so at some point testing on the real precious moon dust needs to happen. But 3D printing on the moon could go beyond putting a roof over astronauts' heads.
You can print polymers, metals, ceramic materials, and you could print food, you can print stem cells, you can, for medical applications, there's almost no limit of what you could not print. And even more important, what you can do is you can recycle. So you could actually then have a very sustainable operation by reusing stuff you have used for other purposes before.
So a robotic version of this 3D printer could make use not only of substances found on the lunar surface, but also raw materials transported there in as low a volume as possible.
Exploration in the past has always been about taking everything you can with you wherever you go. Now, this is possible, but it's very expensive, it's very difficult to do. So what we're looking at now is in the longer term, we want to make exploration sustainable and permanent. Oxygen, for example, is something that we need on the moon for propulsion, for rocket fuel, and for breathing. We can get that out of ice at the lunar poles and from lunar rocks, which are made of about 40% oxygen. We're also left with metals, and those metals can be used to make equipment, make materials. The moon is also the only place we can go, it's only 3 days away, to start to understand what it means to live and work away from the Earth. So if we want to learn how to use resources locally in a responsible and clever way to prepare us for going on to Mars and elsewhere, the moon is where we have to do it.
Of course, this won't happen tomorrow, but technological advancement is starting to push forward the possibilities of learning more about the moon, followed by Mars and beyond.
That was Lara at ESA. Back at NASA, I've been meeting one of these semi-autonomous robots which may be sent to help build and then maintain our living quarters in preparation for our arrival. This is Valkyrie.
So the robot is
The robot is currently there.
And you wanted to go
that's
there.
where you want it to go there.
Yeah.
And then you just ask the robot, plan a path to get there. And using its information about its environment, it plans its footsteps uniquely, figures out where to step safely to get across this debris field.
Controlling robots at a distance means that the operator needs the robot to handle the fine detail of its environment. After being told where to go and what to do, Valkyrie analyzes the terrain and works out for itself where to step and where to put its hands.
Also, there are a variety of applications here on Earth for putting a robot in a place that really needs the human hands, the human shape.
There it goes. Getting in the pickup truck on the moon.
David Maston, Chief Technology Officer. The reason I started this company was so that I could go walk on the moon.
You gotten the new solenoids and rewired those?
We did, yeah.
You did, okay.
Maston is delivering payloads to the surface of the moon. We'll buy a big rocket launch. We'll then have our vehicle navigate the rest of the way to the moon, put it on the surface, and then that soft landing then has your payload right there on the surface.
I started this company for a number of reasons. The major reason was the idea that I think that we could do better than we had been doing in aerospace, looking at stuff that I'd done in the automotive industry, bringing the methodologies that we'd started developing in the Silicon Valley.
And we have a bunch of spare cryogenic valves. Tanks are sitting over there. We just grab one and turn it into a methane tank.
Maston right now is about 15 people full-time. Majority of them engineers that are both designing and installing and turning wrenches and flying, and the majority of the team is based here in Mojave.
Throw away everything that's just nice to have but not required.
We're one of the few companies that was awarded a master contract by NASA for delivery of payloads to the surface of the moon. This is all-inclusive, it's lab to surface.
The biggest thing for competition with SpaceX, Blue Origin, other billionaires is to find other niches in the marketplace. Stay away from the big, huge launch vehicles, stay away from human landing vehicles for the time being until we can get into a much better situation where we could possibly stand toe-to-toe with a billionaire who doesn't care how many billions he throws at the project.
The answer of why go now is that we have reached the inflection point where the ecosystem is able to offer us access to the moon at a price point that is reasonable to unlock the potential that exists on the moon.
Mass knock to all, 6-second count to engine start. 6, 5, 4.
When are we looking to land on the moon? As early as 2022.
And I'm afraid that's it for our mini exploration of space. These folk have a few more days to go yet, I have to say, but I hope you've enjoyed the journey. It's been fascinating, hasn't it? And if you have any comments, then get in touch. We're on social media, on YouTube, Facebook, Instagram, and Twitter at BBC Click. Thanks for watching, and we'll see you soon.